Okay, so the last talk here will be given by myself. My name is Aniket. Very brief introduction about myself. I typically look at the problem that I call as people-centric security and privacy problem, and I try to solve them using distributed systems and cryptography. So I focus on anonymous communication and privacy-preserving protocols, such as which I generally put in the name called communication freedom, and so then try to apply my knowledge in cryptography and distributed systems for blockchains. And that is what I'll be currently focusing on this talk very quickly. So why people got excited about cryptocurrencies in general, and I guess I don't need to say it in this group, but still a nice reminder that, hey, they saw it, they are fast, they saw they are cheaper, there is no central authority, yay, and they are digital, still private. Okay, as it turns out very quickly, all of these things are wrong is what we realize. Okay, that obviously they are not fast. I mean, we cannot use them for point of sale. They are not at all cheap. I won't use them to pay for my dinner unless really I feel like doing it. I'm a very rich guy. Okay, no central authority. People have shown that the distributed index or whatever we can call for the systems is even less than 20 for most prominent systems. And privacy for Bitcoin or several such currencies has been already been a topic which is shown that it apparently almost does not exist, and we can really assume that they are even worse as compared to the centralized solution that we already got. So in this talk, I'll typically focus on the privacy as well as how to make them fast, kind of respect. So what's the blockchain scalability challenge? So that's associated with the low transaction rate. So here I'm putting the number for Bitcoins that we can only manage very few transactions per second, and even when the transaction is small, the number is less than 10. So I'm just giving here a upper estimate of 10 transactions per second. On the other hand, on centralized solution like Visa or Master, they always are and can easily manage 10,000 transactions per second, and actually they demonstrate that they can do even much faster in the peak period. I mean, when there's a particular event, they can even go up to 50,000 transactions per second. So there have been already a lot of talks, even here, how to solve these solutions, and the prominent thing that where people talk about sharding, where they will try. It's not necessarily that every transaction and every information is present with every node. There is the second thing. People say that maybe we can build faster and better consensus. We saw talks regarding that even yesterday. That how can we improve the whole process with vertical scaling as well as horizontal scaling. And the third approach, which generally I focus on these days, is regarding off-chain payments, or what is known as layer 2 payments. Okay, so very quickly, I'm introducing very informally payment channel. I know that many of you might be already knowing that, but bear with me if there are people who are new to it. So payment channel can be looked as a very some kind of gift card in some sense, where the idea will be we will have an Alice, and she has decided that she is going to pay between 0 to 5 Bitcoin to Bob over a period. Okay, let's say that period is a day or 2 days or some days in general. And what she does is that she actually takes this 5 Bitcoin and create a special transaction which says that there is a deposit, both Alice and Bob is associated with them for 5 Bitcoin, but after a time period, it's possible for Alice to get all these 5 Bitcoin. Okay, and now this transaction is put onto the blockchain, and after once such a transaction is there, now any kind of money transfer that Ali wants to send to Bob, she can send instantaneously by just creating a signature offering the current status of such a channel. Like we start with all 5 Bitcoin associated with Alice, and then let's say 1 Bitcoin goes to Bob and 2 or so on. But the important thing is all these payments doesn't need to go to blockchain. They just remain with Bob, who makes sure that they remember the latest stage. And the idea from Bob is that once the time comes close to this timeout situation condition that is decided by Alice, it should make sure to publish the latest stage, so that in this example, what will happen is at the end of the stage, Alice will get 3 Bitcoin back and 2 will go to Bob, which is the transaction that Bob has received. Okay, I'm showing here only for one directional. We can have bidirectional channels, and several other interesting possibilities are possible. This is also extended with other interesting things like state channels and other systems on Ethereum. But for our discussion purpose, this simple idea is sufficient. Okay. So it's not necessary that we have to keep creating such channel with anybody and everybody that we are performing transaction with. Interesting thing could be that we can actually create a network of such channels and possibly perform transactions which start from one node in such a network, goes through fewer hops, and then end up in with the somebody who is at the end of the, or somebody who wants to want to perform transaction with. So here I'm just showing a simple case where, let's say, Alice want to pay to Cat, and what she can do is that she can, let's say, pay 1 Bitcoin to Bob, and Bob can pay 1 Bitcoin to Cat, and that's the way it's possible for Alice to pay 1 Bitcoin to Cat. And as you can see, from Bob's perspective, it got one, and it paid one, so everything is, the zero sum is there. Okay, but the challenge is indeed here that how to deal with the malicious intermediary. What if Bob first takes the Bitcoin and they say, okay, I'm not going to give that to the Cat. That's where the idea of what is known as time lock contracts comes in picture, where what we do is that maybe we can create that in a two phases, okay, where everybody will first show the commitment and later open that in an order such that it's not possible for some intermediary or even to the Alice and Cat to somehow cheat the rest of the system. Okay, that's the overall idea. The way we do it is the very simple example to do it is what is known as hash lock time contract, where we will and the way we define it is this simple way. We'll assume that there is Alice and Bob, so that's a contract between Alice and Bob, okay, and that contract will have a next thing is value, that's the amount that they're talking about. Then we'll have a condition, and in this particular simple example, that condition will be just an hashed of a pre-image that is haven't been revealed yet, and a time period after which this particular contract or this particular transaction is considered to be invalid. Okay, and the way we are doing it is that in the most simple scenario, we'll assume that Alice will do and value x such that hash of that x is equal to y. And she'll create such a contract, let's say with the first intermediary, and provide that, hey, I'm paying 1.3 Bitcoin to this I1. I1 will use the same variable but change now the sender and receiver and send, let's say, 1.2 Bitcoin to I2, and from I2 it is 1.1. I'm showing here the example that they should generally, they are going to ask for some fees, and that's the reason I'm reducing that value by 0.1, okay? Generally, fees doesn't need to be that high. I'm just giving an example here. Okay. And eventually, such a contract reach where the I3 is paying Cat 1 Bitcoin, and once Cat and Alice, they are talking on other channels saying that, yeah, it seems that I see that Y reaching me, and it seems the same Y that is provided by Alice. Now, what Alice can do is to provide the X, which is a pre-image for this, to Cat, and that allows you to open such contracts such that given that value X, such that hash of x is equal to y, now it's possible for Cat to retrieve the money from I3. And because the same condition used on other side, in most, in ideal scenario, the same value is now provided to I2, I3, I2, and I1, and eventually each of those participants can get the money as required in this particular case, okay? In order to make sure that nothing wrong happens, it has to make sure that that if somebody fails to give the value backwards, but still able to retrieve the money from the front direction, it should be possible for the guys to actually look at the blockchain and determine this value and then appropriately get that value. And that's the reason we have to make sure these time periods T1, T2, T3, T4 are ordered such that T1 is greater than T2 and T3 and so on. Okay, very rough explanation. There are more in nitty-gritties, but for our discussion, this is sufficient. Okay. And this is not just an example. As we all know, this is Lightning Network, which has more than 4,000 nodes and significant amount of network traffic, sees this thing, and Rider Network and Seller Network, and there are several other examples which are getting built in this such system. So what are we going to talk in this scenario? So my aim will be to present some interesting challenges which are present there, and see how those things can work out. And so the first thing that I start with is what we observe as a wormhole attack. So in this particular example, as you see, that we are using the same condition which start from Alice and some intermediate and going to Cat. It's possible for those intermediate to bypass some of the some other nodes which are possibly present in such intermediate scenarios. What I mean by that is, let's say we are using this scenario where we're using same y, which starting by Alice and going into the recipient cat. And let's say Alice, cat realizes that, yeah, this is the same y value, and they start recovering. Cat can use this y value and tell that to adversary. What adversary can do is to completely bypass Bob here in between and take that value directly to the adversary here. This adversary does not do anything. The only thing it does is set that to use that or for its link or its contract with Alice and get the money. And basically, in this whole thing, these two contracts which are created here, which are associated with Bob, doesn't get executed and they expire. Okay. So what's the problem here is that Bob, who somebody puts money on such a transaction, is basically his funds get locked for all these time periods of T3 in this particular scenario without actually getting used. And that's the way you are basically can slow down some nodes just by creating such a tunnel which goes from one node on the close to receiver to the another node which is present close to the sender. Just to give a reference, if you attended Morris's talk yesterday, it's closely related to that, where in this case, basically what we ensure that there is no atomicity in the traditional sense, that it's not all or nothing. Bob here is not losing money, but indeed he is getting slowed down through this process for sure. And that certainly could be an interesting challenge to consider as we see later, because this is related to briefing problem in such scenario. Okay. So yeah, that's what I'm showing you, giving value x, and then payment failed between all these nodes, and the transaction does not succeed. Okay, so the idea why this attack works is that because inherently we are using the same condition when we start from Alice and go until the cat, or go until the cat here in this example. And that's the reason we are seeing this particular attack being successful, because now adversary can just take the answer that it got and send that to some other node which is present there, and it knows that it's going to work. But if we make sure that each of these individual conditions are different and associate with the secret that is not known to the adversary, we can stop such a system. So that's what we did in one of the solution to extending that is that what if we make sure that each of these individual conditions are separate but still linked in a correct manner, then we could be able to avoid such situation as this wormhole attack. So I'm here just showing that example with a very simple 3-node scenario, sender, intermediate, receiver. And now what I'm doing is that my conditions between that is present for the final transaction between the intermediate and the receiver is associated with the term y0. But for my transaction from the sender to the intermediary is associated with XOR y1, which is basically obtained by XOR of x0, which is same thing that is associated with the y0, as well as a newer condition, let's x0, that that will be informed by the sender to this intermediary while even creating the contract. So the idea will be to open the transaction between intermediary and the receiver, you require x0, but to open the transaction between the sender and the intermediary, you require both x0 and x1. All right. So far so good, but at simultaneously to achieve this, what the sender has to do is to prove x0 that indeed when eventually you obtain the x0 value from the receiver, that is sufficient for you to open the also condition which is present between the sender and the intermediary here. And that's basically we require a zero knowledge proof such that there exists some x0, which I'm not going to tell you, but there exists such x0 such that hash of that x0 is associated with this pre-image y0, and XOR of x1 value that I'm providing you, and this x0 whatever that we will get. Again, that XOR hash will be equal to y1. That's a condition that will be present between the sender and the receiver. Okay, and once we have such a zero knowledge proof, you can stop this wormhole attack because now each node has a unique secret x1 or whatsoever associated to them and not known to those adversary nodes so that they can launch it. There is another advantage for us, in fact, which was a primary advantage for us, is that now we are not using the same precondition across different paths of the network, and because of that, it's not possible for the adversary to link different part of the network because they can just look at the condition and based on that determine that, hey, I see same Y here and here, so that means they are part of the two transactions. So by using different intermediate condition, indeed provides much improve the privacy in this particular scenario. Okay, I'm not going to the detail here, but later we realized that it's also possible to solve this problem without requiring zero knowledge proofs or as well as hash function tricks as this perform, but using the scriptless script, which was introduced initially by Andrew here, it's possible to now have a scriptless script also for ECDS signature, and that could be employed to get the same trick, avoid the wormhole attack, avoid the wormhole attack, and make sure that the conditions look different in different scenarios, appropriately providing privacy just using the some version of threshold ECDS. So for this construction, we employ 2 out of the ECDSA scheme, but using the recent work in ECDSA for a more threshold ECDSA scheme, things can be indeed improved any further. All right. The second thing that I'd like to mention here is regarding concurrency. And it's an interesting thing that let's assume a scenario I'm showing here. Let's say we are talking about 2 simultaneous transactions that are happening in such a setting. And my first transaction is starting at Alice and going to Fabi. And my second transaction is starting from Bob and let's say going to Karen here. Sorry, the first transaction will go to Gabriel and the second transaction starts from Bob and go to let's say Edward. And let's say both of these transactions are going to conflict to each other on 2 links. Let's say link between Fabi and Gabriel and between Carol and Edward. And let's say both of them have already committed, let's say the link between Carol and Edward is already committed for the red transaction. And the link between Fabi and Gabriel is already committed for the blue transaction. Now, how can we work with both of them simultaneously? The most simple scenario, what has to happen is that both has to be stopped and reverted back and possibly start with a random delay. The interesting question to ask is that how can we overcome such concurrent situation? Because if let's say both transactions started simultaneously again, they can conflict with each other in the same manner in general. So we looked at this scenario of blocking systems, and in fact we were able to prove that unless we add some kind of an identifier which allows node to figure out in what order they should allow transaction or disallow transaction, it's just not possible to stop such a blocking or such a or ensure that there is a progress into this particular scenario. So the first solution that we looked into is that, okay, we do not allow such blocking and or we allow such blocking but do not add any such identifier. But then when we add such identifier, the privacy again takes a hit because now you can look at just the identifier and determine that transaction starting from this sender and going to this receiver. But on the other hand, if we add the global identifier, we can indeed make sure that one of these transactions always make progress. And what we did from our perspective is to show what is the privacy versus concurrency or non-blocking progress trade-off over here, where we see if we add the global identifier, it's easily possible for 2 adversary nodes to figure out who are the 2 senders, and that's our IO protocol there. So we while on other hand, if we say we are not going to worry about the concurrency issues here, or we are fine to have blocking protocol, we can indeed have slightly better privacy, but on the other hand, there could be blocking that may occur into such a system. Yes, so there also, I must also say that there could be more interesting challenges that could be present with the payment channel networks. In fact, Matt Curl yesterday presented interesting challenges, and some of them has to be considered into this scenario. But here I'm just giving 2 examples that when concurrency and privacy come to each other, as well as the wormhole attacks, which could be relevant. Okay. So I'm going to use the next few minutes from my talk to talk about what are the interesting challenges that are present into this field when we start using such payment channels for interconnect, when in the scenario where they're not just part of one blockchain, but when they go across multiple blockchains. So, and this is certainly real scenario because now we are going to assume that blockchain will get used even beyond cryptocurrencies into general industrial systems. And the application of that can start from payment channels as well as to supply chain. So we can expect that we'll have transactions which start from Ethereum and then go to some Hyperledger Fabric kind of a scenario, which is applied for supply chain, and then eventually maybe end up in something like Bitcoin or Ripple. So it is easily possible that we have solutions that go across such different boundaries of blockchain. And we can certainly assume that there is no one fit for all solution present over here, such that we can just say that we have one blockchain that can be used for all the purpose. It's going to happen that for different applications regarding supply chain and payment scenarios, we are going to have different solutions. So we have to make sure that we allow transaction to start from some blockchain and hopefully reach other blockchains and where the transaction happens. And once we consider such scenarios, so here I'm just showing a very crude diagram of a transaction, let's say that's starting in Monero, then going through Bitcoin and Ripple network, and ending in Hyperledger. For all such transactions, first we have to determine that can we really make these different blockchains or parts of these transactions in different blockchain interoperable with each other, so that indeed such transaction can succeed. Then there are very interesting privacy issues, because to make this transaction happen, we have to have something we can call as the routers here. So that's what I'm trying to show here. That's a two-part connector. So these are the entities which have presence in two blockchains and allow transaction from one blockchain to go into the other system. And now those nodes becomes a huge bottleneck in terms of the privacy as well as in availability. And we have to consider those issues associated with them at all. So in general, it's an exciting space. There is atomic swaps and interledger protocols are indeed taking very interesting step in that space, but more things has to happen. So my rest of the talks will be to talk about some of the interesting challenges, which I know some efforts are happening, but more has to happen, and we'll look at some of those examples. So the first thing I'll talk about is this payment reefing problem. So it's very well possible for somebody to create, let's say, payment channel. You will create a payment channel transaction and send that across network through several nodes to reach a receiver, and don't do anything. Do not open such a transaction. Okay? What can happen because of that is there is a significant money that can get locked in the process through such system. This is called as payment reefing problem in some literature. And that's prepare numerous number of payments and then do not fulfill any of them. And this is form of a DOS attack. Nobody loses money in this case, but it can certainly slow down the system a lot. And people suggested possibility of using what is known as packetization, which is suggested in Interledger, where say we'll not use such locking system as we saw earlier, but in fact what we'll do is that we'll just keep sending small payments to the next person until it reaches the receiver. And then hope is that nobody will trick for such small payment. Let's say I want to send somebody 1 Bitcoin. I'll start with 0.001 Bitcoin and send so many of those small transactions. And if somebody just decide they're not going to forward the transaction to or forward that money to the next guy, we'll figure that out, and we'll now use different paths which are more trustworthy. Okay, sounds exciting, but there are so many challenges here. First, the key challenge is how we figure out which node is functioning incorrectly. And the problem can be narrowed down to one specific scenario where there is one intermediary and there is a successor of that intermediary, and the successor say, I did not get the money, and this intermediary says, I sent the money. And how we figure out this problem in this scenario is very challenging in general. So it's a nice interesting way to look at this bit more in terms of rational case. However, we indeed required significant analysis here and possibly improvement so that we can deal with the malicious scenarios for such packetization. Another thing is that all the protocol, if you look into such system, assume source routing. What I mean by that is that sender knows the complete transaction path from the sender to receiver. They figure that out first and then perform transaction on that. And all the solution I mentioned today inherently require that we know such a route before we start the transaction. Just to give you an example, even when we look at the talk yesterday by Morris, as he mentioned, his diagraph also, you have to know the complete graph. Now, if we consider that that's not the scenario, okay? There are two reasons I see myself. A is that when I look at today's internet, I only know my router, and my router figure out how to go send my package to my destination. So it will be good to have such a scenario where I just know one router, and that helps me to figure out how to forward the packet. Okay. The second thing is that indeed, if we consider this inter-blockchain communication, we may have no idea about how the different network is structured in other part. Okay, it may be a privacy-preserving system. Let's say I'm sending transaction over Bolt or something like that in Zcash system or some other privacy-preserving system, and we have no clue how to reach the destination except that I know how to go to one node in between. So we inherently require approaches which can work without knowing such route. And that's what we can call as a non-source routing, where sender only knows some ways forward. It's a very interesting thing how we can actually have systems which are secure and atomic or some kind of have acid properties that we can achieve for such a transaction. Another thing where there is some things already happening, but again, it's interesting that we may expect that our transaction may not be fulfilled just with one path. So we may have to send our transaction through multiple paths between sender and receiver, and such fragmentation has to be dealt with. There are some solutions to do that already, but the challenge there is that all of them use the same pre-image or same Y and X combination, and it's again challenging from privacy perspective, because assume that we are performing transaction, and for each of these links, it will be same Y that will be employed, and that's again a challenging scenario. So how to do that in a privacy preserving manner is again a challenge, and there is no solution that I'm aware of which is present there. All right. So privacy indeed a big issue over here. I'm not going in detail here, but again, reliability is a challenge. What if we see fork in one network or one blockchain in between while the transaction succeeded in another blockchain? What can we do for such transaction when there is a reliability? And that I generally put those challenges more like a reliability challenges, that transaction succeed in one part, may also succeed in other, but then there is a fork that happening, and how we deal with those is again a very interesting challenge in general. So with that, I'm coming to the end of my talk. We looked into interesting layer 2 solution called payment channel networks, and there are interesting wormhole attacks and other issues with that, which could be resolved. But still, there is a lot to be done, especially when we are talking about interconnecting those, as well, and issues such as non-source routing are really interesting and close to my heart. So if anybody has ideas in that respect, I'll be more than happy to talk. Okay. All right. So with that, I'm coming to the end of my talk, and thanks a lot for being here.